I was working in analytics for a company as an architect, and I was asked to help solve a problem that they had been wrestling with. They had a large amount of data, multiple X billion row tables that they had to extract from source systems and combine into an analytic solution. The real root of the problem was that it was so much data that it took X 24-hour days just to extract the data and get it loaded without any transformations. The data was so large and it was so heavy of a lift to just extract that data and load it that it would cause impact on the source systems, and somebody would wind up not being able to do work and something would get killed. It would start a rollback process and one thing after another. It had been attempted by numerous other people, individuals, before it was handed to me, and they asked me if I could try to solve that. We did get it solved, and I want to look at some of what we did today to solve that issue. But I want to point out that this is something that you're going to run into with analytics solutions. Typically, companies want as much of their data as possible involved in doing analytics. Even if you don't have very, very large data sets to work with, understand that they're going to ask for more and more and more solutions. What that means is they're going to compound and compound the amount of workload, and they're going to begin to conflict with one another. They're going to have contention with one another and with other source systems and the activity that's going on in those systems. So you're going to wind up in situations where processing the amounts of data that have to be processed to get timely analytics is a heavy task. Now, on top of that, think about it this way. If you've got, let's just say, a million rows in a table and one row changes, you don't take that one row typically and just process that one row into your analytic solution. Typically, those analytic solutions are trunked and loaded by most engineers every time that the analytics is built, which is at least once a day, which means daily that one row will get reprocessed from scratch, transformed, joined to all the other data, remodeled, and reworked over and over and over. In order to solve this, you need to look very carefully at what can we do to delta process some of this data, or all of this data, or the data that makes sense to do this with. What I'm talking about is doing incremental processing of your data so that when one row changes in a source system, that one row can be transformed, remodeled, loaded into your analytic solution, and hopefully not reloaded over and over and over again and again and again. We're going to look at a solution for doing this. There are different ways to do it. There are probably a lot of different technologies that can be involved depending on what you're using for your ETL, what you're using for your data warehouse, what you're using for your visualization tools. It's going to depend on what kind of source systems you're dealing with and where that data is coming from, and if you're going to be able to easily get at delta rows. So we're going to look at a solution. This is something that I've done a lot of, and you may have to make some alterations and some tweaks. And like everything else, you're really going to have to look at your use case and make it fit that. This isn't a one size fits all. So let's get started with it. Okay, so here we are. We've created a small sample database for the purposes of this demo. This is to emulate our source database. This is where our transactional system would be in a typical company. And what we're going to use to do our incremental processing is CDC. It's kind of a no-brainer if you're working in Microsoft, because CDC ships with Microsoft SQL Server and there's no additional licensing cost. It's pretty easy to implement. I shouldn't really say the CDC itself is easy to implement. The ETL pieces and applying all of this data to your overall analytic solution is not trivial. This is not a junior developer thing to build, but CDC itself is pretty easy to spin up and get running and to use. Also, many of your new modern cloud data warehouses come right out of the box capable of working with CDC. So it's really easy in some environments. In other environments, let's say, for example, you have Oracle source systems. In order to use CDC with Oracle, you really are going to have to purchase an additional product, and those licenses for those products are pretty expensive. Golden Gate is one, Click is another one. They're both pretty expensive. You can do CDC with Oracle without them. I've done it, but it's pretty brutal. So CDC is one option. Another option, depending on your source environment, may just be processing your own deltas based on stamps and things like that, watermarks. But CDC is very easy if you are able to use it to just be able to recognize what's changed and how it's changed. So that's what we're going to use for this demo. Now, in order to keep this small, we're only going to use a few dimension tables and a stripped down, smaller version of fact tables so that it's all pretty quick, because dealing with hundreds of millions of rows and a dozen different dimension tables really doesn't do any good as far as demonstrating how CDC works and how to incrementally process data. So in this sales database, in order to enable CDC for the database, this is all that's required. We run CDC enable. Now CDC is enabled for the entire database. When you run CDC enable table and pass it a few parameters, it sets up CDC for the individual table. What that means is the SQL server in the background creates system tables that it will automatically keep track of all changes to the base table. It'll record every updated row, every insert, every delete, and all of the values associated with those so that we can process them into our solution. The first thing that we want to do is update one of our dimensions. So we're going to create a single update as if we went to a specific customer and we changed something about that. Let's say, for example, that customer is moving from one location to another, so they're going to wind up in a different area code. And we'll update this customer. And there we have an update. We'll also insert 5 minutes worth of activity into our fact table. And this is actually going to go into our fact table. This is emulating this number of changes in our source system. So we basically processed 50 rows to represent what might occur in 5 minutes worth of time. We're also going to insert another table with the same amount of data because it's used in our solution. This would be another table that's joined for our fact table to create it. Okay, before we start working with this data, let me run a couple quick queries here. This is queries against the 3 tables that we ran inserts and updates against. This shows you that CDC has been capturing this data. This is our update to customer, and you can see that we've got both the insert and the delete part of the update. So the data that came out of the table and the data went back in to replace that data in the table for the update. Then we have 50 rows inserted into each of these tables, and these are all the values associated with those inserts. Okay, when we process our updates, we're going to both delete and insert because it was an update that occurred. In this case, you'll see one row deleted and then one row inserted in the stage. So we basically updated that stage value for that. When we come to the inserts for our fact tables, we do the same thing. We perform a delete followed by an insert. But I want you to notice nothing was inserted or nothing was deleted, but 50 rows were inserted. Why is that? Well, it's because these were inserts. There was nothing already in the stage table. The reason we do a delete followed by an insert is if this gets run again, we don't wind up with duplicates. So the same thing on the next table. The next thing that we're going to do is we're going to create tables with just our delta data in it for the sales order. And we're going to do the same thing for the sales table. This is going to give us a table with nothing but just the delta rows. The next thing I want to show you, this is the row that would be updated in our customer table, our dimension, and this is what the row looks like that would be updated. We're not actually going to do this because this is an instance where dimensions really should be handled as slowly changing dimensions for things like customers. And so we're not just simply going to update that in place. What we would wind up doing is leaving the original row in place to be reflected on all transactions up to the date of the change, and then a new row for all transactions after that. This is going to be handled in a different video that you'll want to watch for slowly changing dimensions, but it's outside the scope of this because if we try to cover both in one video, it's just too much. So now we're going to switch databases to our Delta Lake objects. This is the database that we use for all of our staging data. This is the insert that we're going to do to our fact table. Now this table is very large. It's 124 million rows on this system, and it's running on a laptop that doesn't really have enough memory for that much data. So it's pretty slow to work with when you're building this entire model. We build this model in other videos, and we kind of go through a lot of this detail as far as doing the ETL work. So we're not really going to go over it here. But what I want to show you, when we run that, it's almost instantaneous. That's because even though it takes quite a bit of time to process 124 million rows when you're joining several tables together, it doesn't take very long to process 5 minutes worth of activity in even tables that are that large. The next thing we're going to do is we're going to look at creating some views to make this data smaller. So we're going to create filtered views that represent the 5 minutes worth of data that we just added, as well as the overall table, but a much smaller version of it. Instead of working with 124 million rows of data, we're going to work only with a subset of that. So we're going to only whittle it down to a time frame that's going to give us something like 9 million rows or so. Now, if we run selects against those, we've got 50 rows in our current day version, and we've got about 9 million rows in the version that we're going to look at using for our solution. This allows us to take this 5 minutes worth of activity and apply it to an individual partition in our solution so that we can process that bit of data over and over and over. So 5 minutes later, we might apply another 50 rows. 5 minutes after that, maybe another 100 rows. 5 minutes after that, another 20 rows. But we wouldn't have to process the entire 9 million or 100 million or hundreds of millions of rows entirely over and over and over again. Every time we want to update the solution, we can get away with only updating what we have to make the solution work. So here's where we're at. We've pulled our data from the source system, from our RDBMS, which is sales. We've pulled the data that we want into our stage area. We've transformed that data. In the real world, we will have mastered it. We will have governed the data. We will have cleaned all of the data up and remodeled it into a dimensional model so that it's ideal for our analytics purposes. From here, what we want to do is we want to load this into something for reporting. In our case, we're going to load this into a tabular data model. This is going to be used in SQL Server Analysis Services. It's the same database engine that's used for Power BI under the covers. It's fast because it's columnar and because it's an in-memory database. It only works with what it can fit in memory. If it no longer fits in memory, it no longer will load. So you have to add more memory to whatever machine you have that hosted on if you don't have enough memory. That makes it very, very fast. So We'll come over here and we'll look at this data. And what we're looking at right now, this is the data we've loaded, our customer, date, product, reseller dimensions, and our fact table, which again is the filtered version that we use to view to filter down from 124 million down to about 9 million rows. And we've got that table broken down into two partitions. If we look at partitions, one of those partitions is a little over 9 million rows, and the other one currently only has 50 rows. This was to demonstrate the example of taking 5 minutes worth of activity and loading it all the way through our ETL process, which was virtually instantaneous, and getting it out there to where we could load it into this memory model. What we're looking at right now is the date 2020-6/16, which is the one day that we were loading our Delta data into. So if you remember when we were doing our ETL, there was basically 50 rows that we loaded from CDC. We updated data in our sales table and we used that CDC data to find the 50 rows that changed and pull them in to our stage area and then to rebuild our fact table to include those 50 rows of data. It was all virtually instantaneous. Now we're looking at specifically order line from our sales fact table and the sales amount for each of those lines. If you'll notice, there's 50 lines worth of data here, and it's all for 2016, which again, if we look at the partitions, if I could just use my mouse, there's 50 rows in that partition. Now, if we clear what's in that partition, and I guess let me show you how to do this in the GUI first. If we go back to our partitions, and this is the icon to process, and we want to choose this one to process, and the process that we're going to choose is clear. Now, if we want to script this, we can click this button and it'll give us the code to do this, and that's what we'll look at here in a second. But when we clear this, just about that quick, it's going to remove those rows. So now you'll notice there are 0 rows and it shows that it has not been processed. All of the data has been cleared. Now, if we try to run this same data here, what we're going to see is that it no longer works. If we click the execute query, now we're going to get an error because part of the data is missing because we've cleared the data that was in the partition because we wanted to test processing that. If we come over to our script window and we do a process of only the one partition and we process only the data for that partition, it's very quick. Okay, as you can see down here, this took 19 seconds. Normally it takes about 6. It took longer because this is running on a laptop that currently has a bunch of other stuff running, which means there's less memory on that laptop. Less memory for SQL to cache the data, less memory for analysis services to build the tabular. So it took a little bit longer, but it's still fairly quick. Okay, if we go back to our tabular database and we look again at our partitions, we can see now that the 50 rows have returned, our data is returned. However, if we go back and browse our cube and we refresh the query again, we run into some problems. It does run some queries, but some things begin to give us errors. If we had, let's say a Power BI model, and the Power BI model had, let's just say, for example, the sum of the sales amount specifically for the day that we have data filtered, and then we have data for 6/11, 6/12, 6/13, 6/14, 6/15, and then this one day that's only got 5 minutes worth of data in it so far, and we refresh this one, is not going to like it at all. And that's what you're going to get. Now, The reason is, even though we've pulled this data in, when we process only the data, the new data is now in the cube, but tabular models aggregate the data every way that it can be aggregated. And if there are multiple partitions, it aggregates across all of those partitions, which means there's now some missing links between data in this partition and the new partition and the data that's aggregated across them, which means you have to do a more full process to get all of that to work. Now, this is somewhat going to depend on what you're doing in your solution, what data is being touched, and if the data goes across multiple partitions, and if the data goes across multiple dimensions where that has to join within that tabular database. But in this case, we're going to run this. This one's going to take considerably longer. This basically is a process default, which means it's going to process whatever needs to be processed to make the data all make sense. There are a number of different types of processes you can do. You can do full, or you can do table, database, partition. You can clear partitions in a process. You can do the default or data only. In this case, default means process whatever you need to make the stuff work. We're going to let this run, and we're going to come back when it finishes, and we'll see right down here how long it took. Our default process finished. In this case, it took, you can see, 6 minutes and 40 seconds. That's extremely long for this amount of data. This laptop is really overwhelmed right now, and everything's running off a disk, which means it takes exponentially longer. Normally, a full process of this whole database takes a fraction of that time. So it's really kind of slow, but that really isn't the point of all of this. On server hardware, you'd have it sized for the work that you were doing, so it really wouldn't be this factor. Okay, let's go back to our tabular model and see what we have now. If we go to our partitions, again, we see about 9 million rows in our primary partition, and today's partition, the day that we're processing deltas for, we've only got 5 minutes worth of data in there, so we've got 50 rows. If we go back over to our browse and we refresh our data, it all refreshes. Now, here's the key thing. Because we've pulled this data from the source system and staged it in another environment, and we're doing our ETL work, or building our dimensional model in a different environment, that work that's occurring doesn't really impact the source system any longer. And none of this work where we're loading this model impacts the source system any longer, which means we may be able to pull data every 5 minutes from the source system using CDC or some other delta processing mechanism and load it into our dimensional model. We may or may not be able to do the kind of processing that we want to do to get our solution to work in that same 5 minutes, but that's okay. We might be able to get away with processing it every hour, every half hour, every 2 hours. We might be able to process it in the morning, and then around noon, and then early afternoon, and then in the evening again, or something like that. It really just depends. We need to look at our use case and what we can get away with doing. But here's the thing that's important to know about this. When we process this model, and we'll go ahead and just start a full process, and that is currently running. While that's still running, we can still refresh this. If we pull our Power BI report back over again, which wasn't working before, oops, let me get rid of that, wasn't working before, and we refresh it again, it still works. So we still get data. The reason is when you reprocess a cube, it leaves the current version of that cube in memory and is available until the reprocess is completely finished. Then it removes the original and replaces it with the new one. So all of this data then is available all the time. You can process all the time throughout the day without really impacting users. Look, I know this is a lot to take in. If you don't work with these technologies day in and day out, if you don't already work doing data engineering and data analytics, this is an awful lot to take in. If this were a training course, if I was teaching this as a course, this would be a full 1 week course easily to cover this much information. I'm not trying to teach how to do all of these bits and pieces and nuts and bolts and put this together, only show you what's possible with these technologies and what things you need to be aware of to try to make things as efficient and as economical as possible. If you decide that you need help implementing some of these things, I'm available for that. And there are people that do this kind of work all the time that can help you with that stuff too. But it's important for you to know that these things are available and the impact that they can make in being able to get your data available without impacting your source systems and in a very timely manner. I hope this really helps you. Feel free to reach out if you have any questions or if you need any help with any of this stuff. Thanks a lot.